32-bit IP address plus your RD, which is your 64-bit, overall 96-bit. Now, why we are running MP-BGP? Now, MP-BGP we are running here. Understand the topology first of all. MP-BGP we are running here. Now, why we are running MP-BGP? Because to carry this VPN v4 route, okay, we have only one protocol available right now. It's called BGP. Only BGP support VPN v4 route. If tomorrow the other protocol will also start supporting, maybe we won't use MP-BGP, multi-protocol BGP. Okay, and we have learned something called community your attribute in BGP. Now try to understand, it's like a tagging concept. Another concept is called RT, which I'll let you know. Okay, so let me complete the basic part. See, on the provider edge, what I was explaining you, it's an edge router, MPLS forwarding to the P router. Okay, here on the provider edge, you are running IGP protocol, you can run BGP, P to C routing is different. Okay, what it distribute VPN v4 route via MP-BGP. Okay, which has RD, RT, VPN labels. A lot of things are there now. Okay, theoretical, I will write all these things, but just get an idea. First idea will be you have to have put 3 practical, different practical will do for MPLS. But in this very first practical, you should get the functionality, how it works. What we do in a P router is a core router. It is called MPLS cloud. Okay, P router do not need to run BGP. Okay, and do not have a knowledge of VPN. Switch packet based on label. Now, just give me a second. Sorry, I'll write all these points for you guys, so that will be easy for you. See, first of all, this PE router. One P router, nothing. Sorry, this is called customer edge router. So the customer edge router, VRF associates to one or more interface. So you are associated with the VRF, a customer. Now, every customer has its own routing table because of VRF. Routing table and forwarding table. Just that. Now, if you have noticed, I have told you different instance of VRF is running, which I can say, I can make that point on the P router, and what C will do, it connects to the provider edge router. Now try to understand, nothing much configuration on your customer edge, R3, R4, R7, R6. Easiest configuration, and the P router. Just you need to enable OSPF and run MPLS. What, where, and main troubleshooting will come, main configuration will come on the PE router, R3, or if you will notice R1 and R2. They will be the most important router. Okay, because now try to understand here what I'm saying, that MP-BGP will going to take your VPN v4 route, right? Or these routes will come here. Now static BGP, RIP BGP, OSPF BGP, EIGRP BGP, they're not same protocol. So we need to do here redistribution also. Got it? So once we redistribute those routes, once it will come to MP-BGP, it will become VPN V4 route. Okay, so again I'm telling you, just get an idea. Because a lot of theoretical part here you need to understand. And it will be followed with your service provider also. If you are good here with MPLS, that will be good and easy to learn service provider MPLS part. Now, in PE routers, I am making a note. This is called MPLS edge router. Okay, it forwards packet to P router. Okay, now in here we have a concept of PE to CE routing. Okay, now if you will notice, on the same router I am running different instance of routing protocol. Different instance of routing protocol. Meaning here I am running static, here I am running RIP with VRF, here I am running OSPF, here I am running MP-BGP. So a lot of load is there. We need a high-end router. ASR routers mainly we use. Okay. Now what actually it does, okay, it distributes VPN V4 routes to via MP-BGP. Updates are sent via MP-BGP. Okay. So with that, you have one RT and one VPN label also. Now these things I have to explain you, and it will be carried here. Now as I explained you something that, okay, why we have a concept of, not two concepts, first of all, put that thing in your mind, then I'll come with the third one. We'll go with very rough ideas, okay, so that you'll get a concept. One is called route distinguisher, which is called RD. Other is called route target, which is called RT. Now route distinguisher is an attribute of VRF, and route target is an attribute of BGP. That too, it is a part of extended community. Whatever we did in BGP called standard community, it comes under extended community. Okay, so that basic thing you have to put in your mind. But why we need RD and why we need RT? Now when it distributes the route, okay, we are talking about right now control message, but I'll come to that. Plus we have something called the third label, which is called, I have told you in MPLS VPN we have two labels. So I'm talking about a second label here called VPN label. I have all the scenarios set for this. How you're going to understand. Now what happens is, when an update is going, why we need RD? Because I have told you these routes could be an overlap. These routes could be overlapped. So to see, if suppose you are two similar looking, your brother, twins, okay, and you are wearing same shirt, same jeans, same shoes, how would I recognize that who is like Mr. A and who is Mr. B? Because first of all, you look same, the physique is same, you are wearing same clothes. I cannot differentiate. For that differentiation, they put a tag called RD. Okay, this RD going to explain it 10, 20 times now. Okay, so that you'll put this in your mind. And now try to understand. See, if I will ask you in the switching, this is a trunk link. when you have learned switch concept, it's a trunk link. And this packet is coming from VLAN 10, this packet is coming from VLAN 20. Now trunk link carry multi-VLAN information. VLAN 10 is also going out, VLAN 20 is also going out. What they do? They put a tag. Now why they put a tag? So that when packet will hit here, see on the trunk link multiple VLAN packets will come. How would trunk link will come to know that to which VLAN this packet belongs? So that's why we put a tag, right? Same thing, to which VRF you belong. When packet will reach here, this is not a VRF interface, this is a global interface. Okay, on this global interface, when packet will hit here, now this packet belong to which VRF? VRF A, VRF B. It's same like VLAN concept. To which VRF you belong? Their RT will come in a picture, route target. First of all, make one thing clear, what is RD, RT and VPN label, I'll come to that. Okay, but here right now focus is right now on RD, RT. So actually what happened, a customer has sent the route, here it did redistribution. When it did redistribution, RD, that route will become VPN V4 route. Now VPN V4 route will be handled only by BGP. So it will be carried by BGP, indirect neighborship we have. Okay, and when suppose a route is coming, say this is the route you are sending, RD will be there, RT will be there with that route and VPN label. That is what it will going to carry. And with the help of this RT, it will segregate that whether you have to go here or you have to go here. Okay, if we talk about P router, P routers are the simplest router, means for understanding. P routers are in the core. Core of the MPS cloud. Okay, P router do not need to run BGP. Okay, do not have a knowledge of VPN. It doesn't care even like customer P router, they do not have any knowledge whether it's a VPN or what. It's router point of view, not for us. So it to switch the packet based on labels, whatever we learn. Which is called swapping, not IP. Okay, so this is like a small overview on this. Okay, I hope you have revised MPLS and VRF. Okay, so my focus will be first of all I'll clear this. So I have explained you the topology, how things will work, how we're going to do practical. But before that, I will give you different scenarios on RD, RT, and VPN label. So I'll come back to my notepad. See, three things are very important here. In your CCIE R&S, we have to understand RD, RT, and a VPN label. Then the advanced part comes under your service provider, not in this curriculum. Okay, you have route target, route target. Route distinguisher, I'll start with. RD, route target, RT. Okay, and we have VPN label. Now, first, people see, most of the people, what they do, they learn only route target and route distinguisher. I don't know why they skip VPN label. It's a very important part. Okay, so just because it's very so many things are there, maybe they get confused. So first of all, you need to segregate one thing. Two things are there. Like we have learned routing protocols also in CCNP. Okay, you have one called control message. Control messages are like when you send OSPF, EIGRP updates, when they exchange routes. Okay, other is called data message. When you're trying to send a ping or you are trying to open a website, whatever, that is called data packet. So control messages, under control messages, your route distinguisher and route target will come. Whenever you're exchanging the routes, it comes under control message. And whenever you start initiating a data, at that time VPN label will come in a picture. So data traffic, data messages, whatever you want to know, or the way you will understand, make a note. When you're sending a route updates, okay, like here MP-BGP updates are going, we are learning about the routes. That time your route distinguisher RD-RT concept will come. Now when the time you will initiate a packet, suppose in the example I will show you with ping, whenever I will do ping, now ping comes under data, so at that time, okay, VPN label will come in a picture, RD-RT won't come. Okay, so that basic concept is put in your mind. Then with respect to that, right now I'll give you one scenario. Okay, see, first of all, I'll take single VRF. Then I'll take multiple. Or if you want two or three, I'll take two VRF after that. Okay. So how RD-RT will work? Okay, then I will talk about VPN label also, step by step. See, this is your VRFA. Here also you have VRF. It could be A, B, whatever. Now, when you configure IP VRFA, inside that you configure RD and RT also. People get confused because under VRF we configure RD-RT, so they think that RT also belongs to VRF. RT is the concept of BGP extended community. RT is not a concept of VRF. Okay, RD is an attribute of VRF. RT is an attribute of BGP. So that I will theoretically, when I will give you a proper note, I will again mention it. Now, suppose this is 10.1.1.0. As I've told you, okay, I'll put VRFB also. Now, VRFB, I have told you there could be an overlapping. So the question is when both routes are going out. See, this is not a VRF interface, this is global interface. It's like a trunk link. It carries all VRF information. So when 10.1.1.0, here also I'll create one VRFB. Okay. So, and from here also an update is coming for similar route. Problem here is they both look similar. See here two tags are there. Both tags have different functionalities. So see they are similar looking guys, wearing same clothes, same shoes, everything is same. Okay, plus they are twins also. So how you will going to segregate? Same thing, right? If you overlap mean they are similar IP. First of all, to which VRF they belong, that is the second part. Okay, that is second tag. But first tag we need to put that they should look different. Here comes the configuration we're going to do. I will give RD here. RD 100:1. Now RD is, suppose I gave 100:1. Detailing I'll give you how many bits, how many bytes they are long, those things later part. Here on router B I gave RD. See the time. See in interview I will ask you, if I will give RD here 100:1, what will happen? First of all, you have to tell when I will show you practically. When you will give same RD on a same router, it won't accept. Now try to understand why it will going to accept. RD should be locally significant. Reason is I am putting this tag because they should look different. Now if tags are also same, see if I will say that iCard, I am putting a tag on them. Suppose I will put one ribbon on them. If both ribbons are also same, then why we are putting tag? How they will going to differentiate? So that's why it will throw an error. So you cannot like, I won't say that make sure that their RD will be different. You cannot even write. It will throw an error. So RD has to be different. So it could be like 100:4. 100:1 plus 100:4. Now this complete route, whatever you can see. Now this is what I put RD. This is what I put RD. Now actually it became now your VPN V4 route. VPN V4 route. And you cannot carry VPN V4 like this. You have to run here to here. MP-BGP. Maybe in between 1000 core routers are there, I don't care, but on the provider edge to provider edge, you have to run MP-BGP because this is a VPN v4 route is only supported by MP-BGP. Supported by BGP. Now VPN v4, as I've told you, it's a 96-bit. Detailing I'll give you. Okay, but right now just get the concept. In this scenario, I will just teach you the concept. Now, any route will come from this customer edge to this provider edge. It will going to put RD. Whether they are overlapped or not, I will going to put RD. That is the functionality of RD right now, because we have overlapping issue. So to resolve that, we need RD. Yep. Now there will be one more tag. Problem is when these two routes will reach here, you have two VRFs. VRF A, VRF B. Now to which VRF they belong? As I have explained you, it is the same concept where in a switch on a trunk link, When a packet reaches to which VLAN you belong, we put a tag called VLAN tag. So VLAN 10 will tell that go give it to the VLAN 10. Right? So similar way, now we will going to put one more tag called RT. So right now just we have to understand when RT will, again RT is a 64-bit tag. RD both are 64-bit. RT is again 64-bit tag. So this RT will, when it will reach here, these both route. This belong to VRFA, this belong to VRFB. Who will decide? Here decision will be done by RT. So RT will decide how actually import export commands are there. We're going to discuss. So here RT will decide to which VRF you belong. Okay. Now, when you're sending an update, okay, here only see the way I gave configuration. Here only we do configuration for RT also under this. RT has few more things, but just right now try to understand. This is what an overview, not a proper packet flow. I have told you still. This is somehow you got an idea that this is how control message works. Similar way, now these are like when you're exchanging the MP-BGP routes. That time this concept will be there. Okay, where to install on which routing table you will going to install the routes, and that will tell RD will segregate. Now with this update you are sending one more thing called VPN labels. I'll explain you how actually it works, but right now just understand with these updates VPN labels are also going. So according to the RT, VPN label will go to the separate according to the VRF, particular VRF. Now, when you initiate a packet, suppose you did a ping, you initiate a packet. Now in the packet, if you notice that you have L2, L3 in the last time. So one label is there, suppose 617. We have one more label. Now, this is called label with the bottom of stack equal to 0. And this is your bottom of stack equal to 1. Now this label will decide this is what you did, push, swap, pop. And this label will, what it will going to do, this label will tell you this is called VPN label. Again, see, for control messages, RT will tell you to which VRF you belong. For data packet, this second VPN label will tell you that to which VRF you belong. You got my point? So these two things are totally different. RT comes under control message. If you notice when I started ping, there is no concept of RD and RT that time. Only we have one extra VPN label. Now VPN label will going to move me towards VRFA or VRFB. Okay. Give me 2 minutes. Give me 2-3 minutes. I'll come back. Just go through. So this concept, will come back in. So I hope you got an idea on a bit about RD, RT, and VPN level. So I'll put a little bit more on RD and RT. VPN level tomorrow more I'm going to explain. So what scenario, one scenario I'll make, 2-3 scenarios I'll show you differently. So right now what I'll focus on, one single VRF will take. Okay, so one by one we'll see all the scenarios and just make a note. See, now suppose this is VRFA. This is VRFB. Okay, so here you have typed RD. Now try to understand RD. I'm typing 100:1. RDs are locally significant, meaning on the other side RD could be same also. I have to make sure that RD should be unique at my end, right? So I'll make it like 3. Okay. Now RT has 2 values. Now this is very important. In Nexus RD, like there also we have MP-BGP concept. There in VXLAN it will come. There RD automatically detects. Okay, because we have to detect unique only, and we are not. If you are not aware what is the RD, it's okay. But RT you should know because we have to do the further configuration here. Now we have 2 type of RT. One is called export. One is called import. Today we'll focus on export and import. Here also I'll put RT, export, RT, import RT. Okay, now you just need to configure export RT, import will be automatically, not automatically, but that you'll get the value. Export means now when you're sending with suppose I'll say 100:4 I'll take. You can write same also. It's up to you. 100:111. Okay. When this guy is sending any route, RT will be suppose 222. Right. So now try to understand what actually it is saying. Whenever I will send an update, whatever route it is, 10.1.1.0/24. So you're telling about that I am advertising 10.1.1.0 with RD value 100:1. Okay. RT, which RT you are sending? You are sending export RT, which is 100:111. I'll put it here. You are sending export RT. Okay. And try to understand import means, see, even we have one more VRF. I have told you RT tag will help you to tell to which VRF you belong. So under VRF, this is called VRFA. I have put import. See, whatever is this side export will become this side import. You have to ask the other guy what is your export. That will become my import. Meaning, when the right route will come here, he will check RT value 100:111. In the import, see what I have to import. I have to import, if any tag will come with this, I will going to put that in VRFA. Likewise, here what is the export? 100:222. That will become import for this guy. So what will happen when this guy will send any update? Suppose he's sending about 30.1.1.0 plus RD value will be 100:3 and your RT will be export RT 100 colon. Always remember, whenever you're sending an update, you are sending RT which RT export. Import means what you will going what which RT is going to receive. So when you will going to hit here, okay, here he will check. Both VRF will check import wherever is a matching import will be. I will going to send it there. If you won't type an import command, packet will drop. Packet is called, when that drop will called ARF, automatic route filtering. Automatic route filtering. If a wrong import tag you have typed. Now these we have to do manually, the RT. Even RD I am doing manually, but here export import should be correct. I have to ask the other side what actually you are using. So you need to first of all understand this concept. Then there is one more label called VPN label, which I will come to that. But right now what I'm going to do, I'll make a bigger scenario. So what I will do, then tomorrow I will put a VPN label and then I'll combine, I'll show you 2-3 topologies. We have to practice. I have to practice with you, okay, so that you will understand. This is easy concept, but people thought, like, I don't know, for them it's endless is the biggest. But this is in CCIE you have to, like, it's the first step of jumping into MPLS. Basics should be correct. So this is your VRF A, VRF B. I'll take it very simple. Tomorrow I'll make one more and I'll tell you more things on this. What we can do VRF B. Okay, because of that RD concept, which is all VPN v4 route, RT will be carried, VPN label should be carried. So MP-BGP is run. MP-BGP is the only protocol which support VPN v4. Again and again I'm repeating. Now here in this VRF we have an RD of 100:1. Here I have a RD of 100:2. Here we have RD of 100:3. Here we have RD of 100:4. Okay, here I will put RD also, all different values. It could be same also, then I'll tell you that it's a little confusing. So export RT will be, I'll start from 100:5. Import will be, I will write. Okay. Here RT. Export will be 100:6. Import I will write. Import will depend on my neighbor, my own other branch office or whatever way I'm connected to him. RT here, export will be 100:7. Import I will write. So RT here, export will be 100:8. Import I will write. Now let me change the color and import. Now try to understand, whatever is its export, that will become this guy's import. Of course, you have to remember these things. Whatever this guy export will become import for this guy. 100:7. Whatever is this guy import will become, sorry, export will become import of the other. And whatever is this guy export will become the import of this guy. So with one VRF, I have told you first, now I have put two VRF. Bit complicated initially it looks, depends. Now, so when I'm sending an update, okay, I'm not talking about VPN label right now, second VPN label. Tomorrow we'll talk about that so that you won't get confused. This is your overlapped IP 10.1.1.0/24, 10.1.1.0/20. Okay, one route is coming from here.
ठीक है, उसको रुकने के लिए बोलो.
Dot 1.0/24. RD will be there. RD is 100:1. So I'll mention this is RD. And I'll mention this is called VPN v4 route. With that, RT is also carried 100:5. Which RT? Export RT. I'll change the color and I will initiate one traffic from here also. Again, overlapped. How to change that overlapped with the help of RD? 100:2, which is your RD. And this is called VPN v4 route. Okay, and then you have RT, which is 100:6, called export RT. Okay, so now what will happen? RD, as I've explained you, here again I'll put, it help you to overrule that overlapping issue. Okay, RT will tell you to which VRF you belong. It's like your VLAN tagging. VLAN tag will tell to which VLAN you belong. It will tell to which VRF you belong. So now when this packet will reach here and this packet also will reach here, first of all, they both look similar. RD will tell, okay, they understood that they both are different. It is like a guy came to an engineering college, suppose I'll say. Okay. Now, first of all, a guy standing here, they both look similar. Okay. Now, one belongs to IT, one belongs to CS. He has a list, but he has a name also, but who is which guy? Who is Mr. A? Who is Mr. B? One tag is when I will going to put RD, they have put one tag so that it is written that I am Mr. A, he's saying I am Mr. B. So RD will, first of all, for this guy, it will be easy to understand that, okay, they both are different guys. Now we'll talk. Okay, now show me your one more ID, which is called RT. That identification is, now here it is written that I belong to IT department. He's saying I belong to CS department. So, okay, I have a list matching, go. Got it. That's why two tagging we need. Similar way, when packet will reach here, okay, here I will check export. So he will check import is 100:5, here import is 100:6, meaning no, it will go to VRFA. When this route will reach here, RT is 100:6. Import is 100:5, import is 100:6, meaning install in the VRFB routing table. Got it. Similar way, if packet will, suppose here we do not see, it doesn't mean that you have overlap. One is overlap could be there. There could be situation overlap should not be there also. So at that moment, suppose 20 route, and I'll make it 50. This is your 20.1.1.0/24, 30.1.1.0/24. So when these routes are going out, I'll put it here. 30.1.1.0. Okay, what is RD? RD will be 100:3. Okay, what is RT? RT will be export. I will write 100:7. Okay, and then if this route is going out, 40, I'll say, okay, this is 20. This was 20. So 30.1.1.0. What is RD here? 100:4. And what is RT? RT always be an export RT, 100:8. So when it will reach here, where is 100:7? Here import. Where is 100:8? Here you have to import. Accordingly, they will be segregated. Okay. So few more scenarios I can teach you. Okay. This is like I have taken the complete one scenario with VPN label. So just revise this today. Tomorrow I will make a similar kind of a scenario, but with the VPN label. Okay, and then I'll give you overall view, and then we can start doing practical. Okay, so tomorrow I'll put it again for a theoretical class. First I will make you revise all these things. Then I will make one more scenario, and then I'll write the theoretical part. Okay, then from day after tomorrow we can start the practical problems. Understand this concept, very important. Okay, so today I'll stop here. See you guys.